This is Dr. D. Govardhan, Professor at Institute of Aeronautical Engineering, Hyderabad. Today the topic is application of wedge and analysis of forces on a wedge. The wedge is generally prepared by using a piece of metal or a wood. Usually it is in the shape of triangular or trapezoidal in cross section. It is used for lifting or lowering heavy loads at a smaller distance by the application of horizontal force on the wedge. Here, the main parts it consists of. This is treated as a ground plane. Assume the body which is represented here, DEFG, assume is to be lifted smaller distance in upward directions. The wedge is kept below the body and apply the force small p toward the right side such that the wedge moves toward the right side. Since it is having inclined, while moving the wedge toward the left side, automatically the body moves vertically upward directions. Since the body is resting against the vertical wall, which is shown in here figure now, to prevent its turning, the support is required. Now, because of action of all the forces, one is the weight of the body W and applied force P. The normal reactions between the wedge and contact surfaces, and since the wedge is moving toward the left side, the friction force is acting toward the right side as shown in figure. Assume these are called here N1 and F1. In second case, when the body tends to move upward directions, the frictional force which exists between the vertical wall and the body, it will act downward directions, and a normal reaction is N3 and the friction force is F3. Since we are drawing free body diagram of body as well as the wedge separately, when we are drawing free body diagram of wedge, we have to consider the forces which are acting on it by the body, that weight we have to consider. Similarly, when you are considering free body diagram of that weight, okay, once again, just I'm giving the forces. When you are considering, when the wedge is moving toward the right side, the friction force which exists in between the surface of the earth is acting toward the right side. Normal reaction is perpendicular to the plane. Similarly, the weight is moving against the vertical wall. The friction force is acting downward direction F3. Normal reaction is N3. The weight is acting in downward direction and passing through the center of gravity of the body, DEF. While analyze the forces, it is required to draw the free body diagram separately for the wedge as well as the body. Hence, we have to consider the reaction force which exists in between the contact surfaces at DG as shown in figure. Analysis of forces on the wedge. The forces can be analyzed for the wedge applications by using two methods. One is the equilibrium method and second one is Leibniz theorem. Generally, the equilibrium method is easy when comparing with the Leibniz principle. It also eliminates the confusions of result of the forces. Now, first I am considering the equilibrium of the wedge. Here I am drawing the wedge now. Wedge is there. The forces are acting here. P force. And N1 is the normal reactions. And F1 is the frictional force. The reactions offered by the weight of the body is perpendicular to the plane here now. Assume this is represented as now N2. And the friction force is also acting along the plane only. Since when the wedge is moving toward the right side, the friction force is acting toward the right side as shown in figure. That is called here F2. These forces are resolved into their component along the x directions as well as along the y directions. So the friction force, when we resolve in two components, horizontal and perpendicular, it is like this. Here, when alpha is representing this inclination, it is also represented as alpha, and this component is treated as F2 sin alpha, and horizontal component equal to F2 cos alpha. Similarly, the normal reactions, it is also resolved in two components. Perpendicular plane and parallel to the perpendicular to the ground and parallel to the ground. This inclination again now becomes alpha. So this is N2 sin alpha, and this component is becomes N2 cos alpha. Now, while writing equilibrium equations, since all the forces are concurrent now, hence two equilibrium equations are enough for solving the problems. That is sigma fx is equal to 0 and sigma fy is also equal to 0 now. Here f1 is equal to, now in this case when you are resolving the forces now, f1 is equal to n1. Now when we are resolving the forces, along the horizontal directions, that is sigma Fx. Assume the forces which are acting toward the right side as positive. So F1 is the positive and P is a negative. Similarly, frictional force, that is F2 cos alpha, again N2 sin alpha, the negative, it should be equal to 0 required. Similarly, the forces sigma Fi is equal to N1 is acting upward direction positive minus the frictional force F2 sin alpha positive minus N2 cos alpha, it should be equal to 0. Okay, these are the forces after resolving along the x direction and y directions and applying equilibrium equations. We got these two equations now. Similarly, the forces between the wedge and the load. Now, on drawing free body diagram of the body, since the body is having certain air inclinations now, earlier we have taken this is our contact area. The body is moving upward directions. Hence, the friction force is acting downward directions. The weight is also acting downward directions. Here, the normal reactions it is acting here. N2 already we have taken, it is a common word. Because according to the Newton's law, action as well as the reactions both are equal in magnitude and acting in opposite directions. Hence, at contact surfaces, the resultant should be equal to 0. Here, when we are drawing free body diagram of weight, the normal reaction is acting upward directions and the frictional force is acting downward directions. Again, resolve the forces in horizontal as well as the vertical since the body is in equilibrium positions and equating the equations equal to 0. We got here and resolve the forces downward directions toward the left side. This force is there here horizontal and vertical directions. Now sigma Fx is equal to 0 when you are taking horizontal forces. Here F2, this inclination is alpha, F2 sin alpha in downward direction, so toward the left side. So this is a N2 sin alpha and F2 is there toward the right side, toward left side, positive. Similarly, N2 sin alpha, it is also toward the left side and positive, and a normal reaction is there, it is towards the right side, it should be equal to 0 required. Similarly, the forces which are acting in perpendicular to the ground now, since F3 is acting downward directions negative, W is acting downward directions negative, The component of frictional force F2, it is equal to F2 sin alpha negative, and the component of normal reactions N2 cos alpha, it should be equal to 0. Okay, by using these equations, we can determine the least force that should be applied on the wedge so that the weight can be lifted. Okay, the summary of this content is the wedges generally it is used to move the or lower the heavy loads along vertical directions. The forces which are acting on it can be analyzed by using two methods, equilibrium method and Lami's principle. In equilibrium method, first of all, we are considering the forces which are acting on the wedge as well as the surface of the ground. On wedge, P force is acting horizontally on a face BC in a given figure. Reactions N1 at AC and a friction force FC on AC. Similarly, the forces which are acting on inclined surfaces, the normal reactions are acting downward directions. The frictional force is acting toward the left side along the plane. By resolving the forces in horizontal and vertical directions and equating 0, we got sigma fx is equal to 0, sigma fi is equal to 0. In terms of applied force P, frictional force F1 and N1, and the normal reactions on inclined surface in terms of N2 and F2. Similarly, on drawing free body diagram of the weight, first identify the forces which are acting on it. F3 is acting downward directions. Since the body tends to move upward, normal reactions N3 perpendicular to the plane. And the reactions offered by the wedge on the body, that is N2, it is acting upward directions. That can be resolved into two components. One is the vertical, one more the horizontal. But the horizontal is tends to slides toward the left side. And frictional force, it is also acting downward directions. When it is resolved into two components, vertical and horizontal, the vertical component is acting downward directions and horizontal component along the left side, and applying equilibrium equations, that is sigma fx is equal to 0, sigma fi is equal to 0, we can determine the minimum force that is required to lift the load W in upward directions. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.